where we know that no one is born knowing how to do stuff. We learn by trying and failing and learning. If you're joining, thank you for doing so, and let's get started. So today we're gonna be looking at taking another look actually at this problem, find minimum in a rotated sorted array. So it's been done before, not submitted, by me at least. So yeah, let's see if we can get through this problem today. Alrighty. So this is find the minimum in a rotated sorted array. We're given an array of length n. It was sorted, it's been rotated some number n. We don't know what n is. We're trying to find the minimum without just looping through every item in the array, which would be the easiest thing to do. We store a min. If we find something less, then we report back, essentially. But they don't want that. They want log n time. So for me, log n is telling me that that's to do with some kind of sorting, or because that's n log n, or actually more specifically like breaking something in half, because when you break something in half time over time, that is like a exponential decay, which is like log n time essentially. Yeah, are they saying that all the things are unique? Yeah, okay, that's good. Great. All right, so let's take a look at how we'd start here. All right. And just wanting to make sure that we are in view in case anyone comes and chats with us. So like, essentially, like we'll have some items here like increasing, and then we're gonna like drop off, and then have some other area where it's like the minimum that we're looking for, and like there's gonna be some value that, like, since this is okay, if it were the full line, it would be something like this. What happened was half of this essentially got broken out and like moved over to this side. Essentially, like that's what we have to work with in this problem. So it's a bit of an overview, but then now I want to have the drawing we had here without the lines going down, because we don't necessarily know that that break is going to happen in the middle. This is that like n line, like the rotation point. But we do know that we want to find this. So we mentioned that like we want to like break this in half at every point, right? So let's look at this left pointer, right pointer, and we'll have some kind of mid pointer. Okay, so if we were looking at the full graph again, left, mid, right, right? So what we have is that left is going to be less than the mid, and that's going to be less than the right. So let's compare that to what we have over here. So here, mid is in fact greater than the left, but mid is also greater than the right, right? So that means we need to go interrogate the right side of this equation more. So like we'll break this up. So that also tells me that this is likely going to be a recursive solution. Just to keep in mind, right? So then now let's look at what we're going to do here. Okay, let's get our eraser going. Okay, so now what we're going to do is we said we would break things. Let's make that happen. So now what like to clarify what's going on, left, or like mid turns into left, and then we make a new mid, and right stays the same. Okay, so now as we said, mid turns into left, we'd make a new mid, and let's say this is our midpoint now, and this is our right point. So now what do we have? So here, left is bigger than the midpoint, but we have what we're expecting, and that the mid is less than the right. So now we're going to go into this section, right? So like, let's write out what we do. We're gonna do the left break. And for that, the right becomes this midpoint. So midpoint transfers to being the right value. We have a new midpoint, and then the left value just stays where it is. Okay, so like we have essentially a framework for the two functions, or three, because we have like some recursive element, but we'll have to create our functions as we go, really. I mean, yeah, so anyway, we drew it out. That should satisfy our log n time requirement here. Okay, and we know that this find min of nums is what it is. Okay, so let's see here. Okay, so we want a midpoint, right? Like, if we have like 12 elements, it'll be 6, obviously, but like that is nums dot length over 2. And like this count will be 0 to 11. So if we were to break this up, and like I'm just thinking as we go, but I'm kind of like, I don't necessarily want us to have two midpoints. Like sometimes you have a situation where okay, sorry, I'm just stopping to pause here for a sec and think. So I just got struck with the thought that like, what about if we have a like 3 element situation, or like 2 elements, you know? I guess we'd have 1 and 2, this would be left, this would be right. If we did like math.floor of the length over 2, like because there's a 2 element array, this is position 0, this is position 1, math.floor of nums.length over 2. Here, nums.length is going to be 2, math.floor of that is 1, or divided by 2. So that is telling us position 1. Is that what we would want? Are we returning the value or the position of this thing? The value? Okay, great. How many items are we getting? We're getting at least 1. Great, also. All right, so if nums.length equals 1, then let's return nums 0, right? Return whichever item we have. Great. If nums.length equals 2, let's just return the minimum value, right? Like return math.min of nums at position 0 and nums at position 1. Great, okay. So, awesome. That gives us like a great clear place to start. And if we're considering this the recursive function that we're going to continue to use, then yeah, you know, that puts us in a pretty good spot, I think. I'm also thinking that what we could do is this whole thing could be the recursive thing. Once we set out like dividing up nums kind of independently, then all we have to do is like find min of nums of either the left or the right side, like whichever side has like one of these divergent situations. We just can return that into the function, and eventually we'll hit one of these edge cases, which is gonna return us what we're looking to find, right? So we'll do find min blank, and like the other case is find min blank, right? Because it's going to be like our right break situation, and this is going to be what we identified as our left break situation. Okay, so if we're considering that we're going to pass in the subset of nums, and like I'm going to write the to-do item of like define subarray for both of these sets. What we need to do, we don't want to forget. Okay, so I'm like, the actual min value doesn't really matter, I guess. Well, let's look at this, right? We started looking at some of our base cases, and I think we should continue doing that. So like, oops, just gonna, let's say we had this 3-item array, right? One, or well, it's rotated, so let's say we had 2, 3, 1. Awesome. All right. So this is left, this is right, and this is mid. So how can we get this to be mid when it's item 0, 1, 2? So this has 3 items in there. Nums.length over 2 is going to be 1.5. Oops. Great. So like this here is position 1. If we did math.floor, that checks out. Awesome. Then now let's reduce some of the stuff around here. Or rewrite this array with 4 items, right? So like 2, 3, 4, 1. This is left because it's the least. This is right because it's the most. So we have 4. 4 over 2 floor is 2. So 0, 1, 2, 3. Okay, this would be the mid. And according to the other things we were looking at, is length bigger than, or is left bigger than the mid? No. Is mid bigger than the right? Yes. Okay, cool. So math.floor is gonna do just what we need it to. Let, oops. So yeah, let left equal, I'm sorry, I'm just gonna write a note to myself here because these are things I always like kind of forget, but array dot split, it could either go from 0 to something or array dot split and just it'll be inclusive of like that x all the way to the end. X to end. All right, so that's a little cheeky note of JavaScript syntax for us. Just coming over to make sure that I'm staying in frame, hopefully so. Yeah, if you're in the chat, of course, as always, feel free to write in if like I'm out of frame or if there's something you want me to like talk a bit more about, etc. But yeah, so left is going to be 0 because it's going to be like the starting position. And actually, I want that to be the value there, so that'll be nums at 0, or like the position. Or wait, no, sorry. I'm just gonna go the value for now, and then that way I could look at like nums left, nums right, etc. But yeah, like let mid equal math dot floor, aka round down, nums dot length over 2, and then let right equal nums dot length minus 1. Okay. Great, so those are like our positions, great. And we know that we have at least 3 items in this array, also great. Okay. Oh, and our values can go down, okay, they can be negative. Okay. Yeah, it's funny because like log n time versus like n log n time, like if it's n log n time, you could sort your array first and then just return item 0, but like, sure. Anyway, now we were saying we're gonna do some comparisons based on the values. So like, yeah, let's do this. So if nums at mid is bigger than num's right value, then we essentially want to run the same function on sorry, I'm just like, if the mid is bigger than the right, okay, that's like our first case here. Yeah, then we want to run it on the right side of this function. So like we'll return find min on the second half here. So like we're gonna do our defining subarray, so I'm gonna just take this out. And we said here, array.split, this is gonna be whatever to the end. So we'll be running find nums on the subarray, or here, we could define it here, let subarray equal nums.split, and we put in the value where we wanted to split, which is mid. Great, okay, and then we'll run find min on the subarray. Okay, and then else if nums, and what do we say? If the left is bigger than the mid, bigger than nums at mid. Oh wait, I'm like, I saw a red line for a second, so I'm like, I think it's just that not loving that this is on a different line, which is very understandable actually. Okay, so yeah, else if this, then what? Then now we're gonna run this with the subarray from 0 to mid, so like the lower half. Okay, and then we're gonna run that find min on the subarray. Okay, so that's our left break situation. We did this to do. So I'm just gonna clean us up a little bit here, and gonna keep my nice notes there. Okay. Whew. Okay, yeah, so we have find min nums. We're running nums on the subarrays. In the cases where we are splitting stuff, and we have our minimum case here. All right, let's run it and see what happens. Okay, split is not a function. I don't think it's splice. To the tools and methods, which sucks because I'm really trying to learn my array methods, but you know, they say practice makes progress and practice makes permanent. So hopefully looking it up means that I will learn it better. Okay, so we have for loops, nested for loops, join, push, pop, shift and unshift. Honestly, that's the thing I was like trying to memorize most the other day. Okay, so splicing can add things, splicing can remove things. One argument given starts from that argument to the end. Okay, splice, not split. Array.splice, 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 array.splice. Okay, repetition is helpful, right? So nums.splice there, and nums.splice here. Okay, let's try again. Okay, find min is not defined. Sometimes we have to do this dot for things to recognize, you know, like looking outside of this function scope. Let's see what's going on here. Ooh, interesting, okay. This must be some kind of base case. Oh, maybe not. Wow. All right, let's see what's happening here. So this has 6 items. Floor of the half of that is 3. So left is 0. Mid is, oh, okay, wait a minute. So what's going on is because we're saying that this is the position, 3. So this is 0, 1, 2, 3, because this being computers start counting at 0. So this math.floor is going to have to be math.floor minus 1, or over 2 minus 1. So that way we're like converting it to being counting in like computer math, right? So this is number 0, this is number 2, this is number 3, but 0, 1, and 2 means we're counting to 3 digits. Okay, so let's run it again with that little alteration. Oh no, okay. Okay, so right now I'm like knowing and thinking that what's going on here is that like the case we looked at earlier where we have 3, half of 3 is 1.5, so it rounds down to 1. We can't have mid be 0. Wait, we can't have mid be 0 and left be 0. Actually, why not? Why don't we keep this as it is and define our case with 3? Right? Because if the length is 3, then like if L is less than M, we return L. And then the other option, like L is less than M, like M could be less than R. Or if it's like 2, 3, 1. Or R could be less than both of them. Okay, how many different variations of this can we have? We can have 1, 2, 3. By the time it comes out being a subarray. Like, does math.min only work with 2 elements? How many items math.min? Yeah, I don't think it has to be only that many numbers, honestly. Like, I think we can add another base edge case here. Interesting. Okay. Yeah, so by doing that, what we've now learned is that like something's going on with our min. Like we've confirmed that from running this way. Okay, so let's they say, is it Occam's razor that says the simplest is always the best? It's like this version had less code. Let's dig deeper into this version. Okay, so let's step through the code as we've written it and see what's going wrong. Okay. Kind of want this to be a little wider so we can see it all. And then this, I'm gonna make as small as we can as well, while seeing the chat. Okay, all right. Chat, stick with me. Hopefully we're not fully cooked yet. All right, so let's try with this. 3, 4, 5, 1, 2. So 3, 4, 5, sorry, 6, 1, 2. So the length equals 6. Length over 2, mid is going to equal 3. Left is going to equal 0. And right is going to equal 5, right? So this is left, this is right, and then Mid is 3, so 0, 1, 2, 3, 4, 5 in terms of positions. So this is going to equal mid. Okay. So is nums at mid greater than nums at right? Yes. 6 is bigger than 2. So let subarray equal nums.splice mid. Am I doing the right thing with splice? Oh, wait, no. Is it? Splicing to remove things. One argument given. Oh, I need to be using slice. Yeah, okay. What is splice doing? Slicing or splicing. Splicing can add and delete things and alters the original array. Okay, slicing carves out and creates a subarray. Okay, so it's slice that we should have been doing, not splice. Right, okay. Slice, 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 slice. They say practice makes permanent. It's like I don't want to memorize the wrong thing, but it's like no better time than this to practice. Okay. Hey, okay, at least now we're doing the right operation, slice. We are still getting the same answer, which is kind of funny though. All right, so yeah, mid is 3. So just checking with our notes. One argument starts from that argument to the end. So here we have fruits.slice 3, 0, 1, 2, 3, right? So that's inclusive, that is what we want. Multiple arguments includes the first up to and excluding the last. That's also fine. Okay, great. So, actually, like, is it? But I guess we'll find out. So yeah, the first one is inclusive, the second one is exclusive. So like inclusive, exclusive, I'm pretty sure with the math symbols. Let's take a look again though. So ideally, now we're going to be looking at this subarray of like 6, 1, 2. We have 3 items here. They said it includes when you do just the one thing, right? Yeah, 0, 1, 2. So this is 3 and whatever else. Great. Okay. Yeah, because we always include the first thing. Okay. So yeah, now we have 6, 1, 2. Left is here. Right is here. Length is 3. 3 over 2 is 1.5. Math off floor of that puts our mid at 1. Left is 0. Right is 2, because it's the length minus 1. Okay, so mid here. Okay. So yeah, if nums left is greater than nums mid, okay, subarray.slice okay, so the first time mid was bigger than the right, so we want from mid to the right. Now, if left is bigger than mid, we still want the right. Okay. Okay, cool. Well, hey now, this and this need to be looking at the other part of the thing. So we'll put this in here. I think I got my symbols backwards at some point. And then this will be the else statement. So like, if mid is bigger than right, which in this case it was, like the value here is bigger than this value, or if the value here is bigger than this value, then we're going to be looking from mid to the top. because that means the smaller thing is here. Otherwise, we're going to be looking here. So that's why this is rebuilt now. So let's run it this way and see. Ooh, okay. All right, I'm sensing some inclusive, exclusive tension here. So, oops. So let's run these numbers and see. I'm just going to remove our cases and whatnot here. Make it a little easier for ourselves. Okay. So here we have 4, oops, 4, 5, 0, 1, 2, 3. Okay. So length is 6, right is thus 5, left is as always 0, and mid is going to be 6/3 floor, or 6/2 floor, which is 3. So this is left, this is right, mid 0, 1, 2, 3, 4, 5 positions, so this is mid. Okay. So yeah, left is bigger than mid. But we do want to be over here. And like technically, for this one, we kind of did want to be over here too, if we had to split. But like I think due to the nature of how slice works, since it includes the first number and excludes the last number, let's do mid plus 1 here, because then we have the chance of like bringing that number down into what we're going to be looking for. And I think going for the left bigger than mid is our better bet, because then in this case we can be looking in here too. So I just undid the function moving that I did, and here now we're going to put this as being mid plus 1, and we're going to run it that way. Oh no. Hey now. This is like a trick question. And it's that way because we're assuming that like left, oops, is always gonna be less than right. Or like, wait a minute. So in this case, yeah, in all of these cases, left is greater than right. Oops. So maybe I guess in the beginnings where we have our guard statements, if like the value at the right is bigger than the value at the left, then we can return the value at the left, because it means it got shifted so many times, let's say, that it like put itself back in order, right? So that should be a guard statement. So actually, we could put that under here when we already have figured out what left and right are. If nums, oops, nums left is less than nums right, then we will return nums left, because we're returning the value. Okay, let's take that for a spin. Oh my gosh! Okay. Excuse me, I'm so excited. We did it. We did it in like a reasonable amount of time, too. Okay, well, if you're following along, thank you so much for being here as part of the journey. As we know, practice makes permanent, practice makes progress. No one is born or wakes up knowing stuff. We all have to learn, as slow as it may be. So, thanks for joining. This is Try Again Dev, where we try again until it compiles, or even in today's case, gets accepted by the criteria. So, have a great day. Thanks for joining. See ya again next time if you want to study together. Bye.